Welcome to the new episode. Today we will continue our discussion on tree. So in our last lesson we briefly got introduced to the tree and different types of trees. Today we will study the tree traversal. That means how we can search a tree, how we can go through every node in the tree. So there are many algorithms developed for this purpose, or you can come up with your own algorithm. However, the point is that you need to go through every node in the tree and search the value of that node in the tree. So up until now, there are two very famous and optimized algorithms for this purpose. One is BFS, the other one is DFS. BFS, breadth first search, and DFS, depth first search. These two algorithms are quite optimized. So in BFS, breadth first search, it says that it traverses the tree level by level. For example, first it checks this level, then go to the second level, and then go to the third level. Here on Wikipedia, there is a good animation. You can see that. For example, it starts from the root, and then it checks the second level, and see when that finishes, then it comes to the next level, and then comes to the next level. It says BFS is an algorithm for searching a tree data structure for a node that satisfies a given property. You can study the details here. Here is the pseudocode for that. So now you know the concept that when you want to traverse a tree, definitely you have to follow an algorithm. There are different algorithms. You can use them, or you can develop your own algorithm, or you can use these two algorithms, which I recommend these two algorithms because they are quite optimized and many people have worked on them, so you can use them. Now let's see how we can write the code to implement BFS, breadth first search. So here let's write a method for that. Public void, let's say BFS. So always when you develop this BFS method, my suggestion is that you need to pass the root of the tree. So because you start searching your tree from the root, so you pass the root, node root. So in this algorithm, the key point is to have a queue, and then add all the nodes in one level to the queue, and then next level and then next level. So let's create a queue of type node, because our class that we used here is node, of type node. We will use that and give a name queue, and we can implement this interface using linked list interface. Linked list interface, of course, of node type node. Okay, so we have created our node here. Let me create that in here as well, so that we can see that visually. That means we are creating a node something like this. So actually I can make it like this so that we can see what we are doing. Okay. So we created our queue. It is the queue we have created here. So sometimes it is a good approach to check if the tree is empty or not. Check root. If it nulls, that means you don't need to do any operation. You return, and that's it. So you say like if root equals null, that means there is no node in the value, so you directly return it. That's it. But if root is not null, that means there are some nodes in the tree, so you have to start searching that. And with BFS, you start from the root and then next level and then next level. So the first thing you do is you add the root node to the queue. So you say that queue dot add root. You add the root to the queue. So we can add that like this also. That means like this. So it is 50 at this point. So we added this node here in the queue, and now when we added the first level in the queue, now we keep checking this queue until all the nodes in the queue is not visited. So we need to have a loop. We say while this queue is not empty, while queue dot is empty, as far as it is not empty, we have to keep traversing the tree. So we say as far as it is not empty, so we have to get the first inserted node to the queue, check that, and then we need to check its neighbors. So we take out the first inserted node to the queue. Node, you can say removed node or current node. I will name it current, equals queue dot pull. So these methods are already built in, you can use them. So when you use this method queue dot pull, that means you get the first inserted node in the queue. You remove that from the queue. When I create this method, that means I remove this number 50 from the queue. Something like this. Now the queue becomes empty. So here I do the operations that I need. For example, if I'm looking for some specific nodes, I make my comparison. But here we don't need, we are not like searching our tree. I just print it. So I'm saying that system.out.println. So let's say current dot value, current dot data. Okay, because our node has data left, right. So we print the and let's have a space also here, like when they print all of them there should be a space between them. So when we printed this one, then we insert its right and left child to the queue. So then I'm saying that if this removed node, if this current dot left exists, that means if it has a child, a left child, then we need to insert this left child to the queue. Okay, why it gives me an error here? So it says type mismatch, cannot convert from node to boolean. Oh, yes. So we can say that if current dot left is not against null, that means if there is a value not null, if it is against null, that means a value exists here. So we have to add this to the queue. So when I'm saying that current dot left isn't against null, yes, it is against null. So then I add this to the queue. Then I'm saying that queue dot add current dot left So I added this node here in the queue. Number 30. Now this one is in the queue, and also I add its right child. So I am saying that if it has a right child, if current dot right is against null, that means if there are any child node, then add this to the queue as well. Queue dot add current dot right. Okay, that means we need to add the 20 also. Something like this. That means right now these two exist in our queue. So this loop continues checking. This time we say, is the queue empty? Of course it is not empty. We have two elements here. So if it is not empty, remove the first inserted node. We remove that. That means we remove number 30. Remove number 30 and do the operation. For example, we print that. And when we remove this, then we check, does it have any children or not? Current dot left, is it against null? Yes, it is against null. So we have to add this to the queue. Add that to the queue. And you know that the queue you add at the end. So add the left child here. $15. And check the right side. Is it against null? Yes, it is against null. So that means we have to add that also, and we add at the end. So that is 10. So it is like this now. And the loop continues. Is q dot is empty null? Of course it is not null. It is not empty. So if it is not empty, then remove the first inserted. That means remove number 20. And then when we remove that number 20, then we check its right and left child. So when we remove number 20, we check, does it have a left child? Yes, it has a left child. So if it has, then that means we have to add this left child to the queue. So we add that also to the queue. And of course it is queue, so we add at the end number 8. And then check its right child. Does it have the right child? Yes, so we add also this to the queue. And that is number 5. Okay, so the loop continues. Is it empty? No, it is not empty. So we remove the first inserted one. That means we remove number 15. And when we remove that, we do the operation here. And then we check, does number 15 has left child? No, it doesn't have. So we do not add anything. And we check, does it have a right one? It doesn't have right child also. So again, we do not add anything. Then the loop continues. Is it empty? Not yet. So if it is not empty, then remove the first insert, and that is number 10. So we remove that. Then we do our operation on that. And when we are done with the operation, then we check, does number 10 have a left child? No, it doesn't have. How about right child? Again, it doesn't have. So the loop continues. At this time, is the queue empty? No, it is not empty. So we remove the first inserted node, and that is number 8. We remove that. We remove that and keep here in the current because we need to check its value. Or here in this example, we print that. And then check, does it have a left child? Number 8 doesn't have a left child. Does it have a right child? No, nothing. Then the loop continues. The loop continues, and at this time, is the queue empty? Still it is not empty, there is 5. So we remove this also from the queue. We remove that also from the queue. And now we do the operation. Like here we need to check its value. And after that we check, does it have a left child? Of course it doesn't have a left child. And does it have a right child? No, it doesn't have a right child also. So that means we visited all the nodes in the array. So now let me call this method on the last example that we had, main class. So we have a tree here, this tree, exactly this one. Now let's call this traverse, BFS traversal method. Does it print all these nodes in order or not? So let's call the method tree.bfs. Okay, we pass the tree.root. So we pass the tree.root, and now let's run it. So you see number 50, number 30, number 20, then number 15, number 10, number 8, and number 5. So it was how we do the BFS, like level by level, and it was how we could visit every node. So in the next lesson we will study deep first search. Until then, have a nice time, and if you have any questions, add your questions in the comment. I will go through your comments, and based on your comments I will fix if there was any problem. Have a nice time until the next lesson.